Next talk is online by Scott Gaudi from Ohio State University, who's gonna speak about the Roman Galactic Exoplanet Survey Project Infrastructure Team. So Scott, you should be able to share your screen.
We're working on it. Can everyone see that?
Yeah, it's good. Thank you.
All right, I'll go ahead.
I will give you the time left. Okay.
Okay, great. So I apologize in advance. There's not going to be a lot of science in this talk. It's mainly going to be a call to arms. Talk a little bit about what it is we need to do to make sure that the Roman Galactic Bulge Time Domain Survey is a success, and the various things that we're doing and the Roman Galactic Exoplanet Survey Project Infrastructure Team to try to enable that. But also, I think my main goal here is to ask for help. To recruit people to help us with all the things that we have to do. So, seeing this plot a lot, I think I really like this plot because it really just kind of shows the overall power of the Roman microlensing survey. So just the litany of science, the list of science that can be done is quite long. We expect thousands of planet detections, including hundreds of free-floating planets, which we just heard a lot about. There'll be some sensitivity to outer habitable zone planets, so we hope we can measure Eta Earth by extrapolation. We're sensitive to all of the solar system planets, or analogs to all of the solar system planets, except for Mercury, so we can see systems of multiple giant planets, maybe even if we're really lucky, systems like Jupiter, Saturn, Uranus, and Neptune. We'll get masses and distances to at least 40% of the hosts. Hopefully we'll do better. Some of them are bright enough we will even be able to follow them up with JWST to get crude metallicities. Obviously, we're going to determine the galactic distribution of cold planets, so how the demographics changes along the line of sight. We're sensitive to planets with mass down to about 100th the mass of the Earth, or that's roughly the mass of the Moon, so we can detect satellites, giant satellites of giant planets and terrestrial planets. Stay tuned for a paper coming out by Matthew Listowka in University of Maryland on predictions for that. We're sensitive to wide circumbinary planets, very complementary to the circumbinary planets you can find with transits. And as we heard from Robbie Wilson earlier in this meeting, we'd expect something like 100,000 transiting planets, when I think people have just barely started thinking about what we can do with that particular sample. So the goal is to try to extract all of this science, and that is not a trivial task. So the goal of the infrastructure team is to plan, execute, and extract the cold exoplanet demographics from the survey, and to help basically the Roman project, the science centers, the other project infrastructure teams, the other WFI teams, the community, and you to be able to go ahead and extract this data. We're trying to build the tools and the infrastructure so that anyone that is even not familiar with microlensing can come in, learn a little bit about microlensing, and extract the data, extract the science from this data set. Sorry, our team is quite large. So far, we have about 75 people that are contributing at various levels. They're distributed all over the world. I should mention the science PI is Dave Bennett. We're always looking for more people to help. So if you're interested, please contact me, Dave, or any other member of the PIT. I just want to highlight three graduate students at OSU that are at the meeting that are working on Roman. Kylie Carden is mainly working on the transit side of things. Arjun Murladhar, who's working on predictions for detecting and characterizing circumbinary planets, and Sinclair Jones, who's working on the prospects for detecting solar system analogs. So please say hi to them if you see them. We like to quantify our ability to achieve our science goals by science requirements. We have 5 such science requirements. Unfortunately, I don't have time to go into each one of them, but they're basically science requirements on the yield of bound planets, with a focus on low mass Mars mass planets, because those are the area that is very difficult for ground-based surveys. Measuring the masses and the distance to the host stars, which is something we hope to do fairly routinely, that requires a lot of extra work to do for the ground-based detections, and a lot of extra observing time. We want to be able to measure free-floating planets. I won't spend too much time about that because you've heard some talks on that already. And we also want to see if we can estimate A to Earth to bolster the measurements from Kepler, which will inform things like the Habitable Worlds Observatory. Um, we have these, our goals, our infrastructure goals are broken down into various pieces. We want to develop a survey simulation pipeline that goes end to end, that you can use to verify our science requirements, test our data reduction and analysis pipeline, optimize the survey strategy, not just for microlensing, but for other science. We have a data reduction and analysis pipeline. The first part of this is mainly being done by the Science Support Center and the MSOS team, who are doing a fantastic job. They're working all the way up to characterizing events and giving us detection efficiencies or completeness. And after that, the Roman pit will take over to determine occurrence rates. And that's a part of the problem that we're going to need help on as well. We're working on precursor and contemporaneous observations to prepare for and enhance the science that can come out of the Roman Galactic Bulge Time Domain Survey. I'm very excited to announce we were recently awarded this past Monday 177 HST orbits to image a subset of the fields likely to be targeted by the Roman Galactic Time Domain Survey. And that's for a variety of science we can get from that, including helping us to define the survey fields more precisely. The PI from that is Sean Terry at Goddard Space Flight Center. And then human infrastructure. I can't emphasize how important this is. The microlensing community in the US is small, and even in the international community is relatively small. There's a lot of science to be had, a lot of work to be done. We really need to grow the microlensing community. We see this as also as an opportunity to diversify the microlensing community by pulling pulling from pools of talent from underrepresented backgrounds as well. And so part of our charge is to help train and develop tools that people can use to bring them into the fold. We hope to have a Sagan Summer workshop on microlensing. Tentatively, we're thinking about 2025, but it might turn out to be the next year after that. So this is our goal, to help the project, PITS, and other science teams in the community. We have lots of active working groups. I won't go through all of them. They are basically focused on the various aspects of what we're trying to do: simulations, event modeling, lens flux analysis, curating a database of variable stars in Roman filters, which will help us test our cuts and understand maybe our false positives. And we're spinning up new working groups all the time. We'll just mention the free floating planet working group that has recently been spun up, that he's co-leading with Naoki Koshimoto, who we're going to hear from, I believe, after me. And then there's others we're thinking about as well. The simulations working group, again, the goal is to develop an end-to-end simulation tool for survey optimization and data reduction. Right now, this is kind of the main focus of our activities in the pit. And part of this is we're going to simulate a bunch of events with realistic properties. Those will help to serve to test our pipeline, but also will serve as the basis of data challenges that we issue in the future. We're trying to verify some of the requirements that remain unverified. And I think the most important activity we're doing right now is trying to optimize the survey strategy, not just for our science, but for other science as well. And Julie mentioned this at the very beginning, but I just want to emphasize how exciting this is. The new slew and settle times allow significant amount of margin relative to what we thought we were going to get, or the conservative assumptions, about 5 years ago, sorry. And that allows flexibility in the survey strategy, and it allows for a lot more science, not just microlensing science, but all sorts of other science as well. And I think that's a hugely exciting opportunity. And so my hats off to the Survey Definition Committee, led by Jesse Christensen and Daniel Huber, who are trying to negotiate and orchestrate all the different science that could be done with the Galactic Bulge Time Domain Survey, and try to maximize all of the different science, the exciting science that this will enable. So there's lots of alterations to the nominal strategy that we've heard about before, that I won't go into. I'll just list it here for your reference. And all of these are being considered and their impact on
3 minutes, Scott.
2 minutes.
Three.
3 minutes, great. Okay, we have a variable star working group. Again, the goal is to create and curate a database of variable stars with the Roman cadence in the Roman filters, with Roman photometry characteristics. This is hard because none of the existing variable star catalogs or time domain surveys have exactly the right cadence or filters or photometry properties that we need. So Rachel Street and Alexander Stefan are working hard on trying to translate what we do have into the kind of data we expect from Roman. One of the things we're thinking hard about is false positives. Will mentioned this in the previous talk. There's a recent study of tests looking for free floating planets in tests that uncovered something that looks very much, you can see it on the bottom right, very much like a free floating planet microlensing event, but is almost certainly a stellar flare. And so this is a very pernicious false positive that we have to try to figure out a way to get around one way or another. Other things that might be false positives or spotting and eclipsing stars. Whenever you move into a new regime of parameter space that you weren't sensitive to before, false positives are always a concern. And since Roman is of course doing exactly that, that's why we're doing Roman. We have to think hard about false positives. We're working on our event modeling and analysis. Won't say too much about this, but this is I think an important goal is to be able to make sure that we can extract as much information from the microlensing curves as possible. We're studying the lens flux analysis. There's a rich amount of information from the actual images themselves on the fluxes of the source, the fluxes of lens, their proper motions, and their parallaxes, all of which can feed into understanding and characterizing the microlensing events better. And of course, measuring the parallaxes of stars and their proper motion is going to be important for all sorts of other science and all sorts of other science that can be done with galactic bulge time domain survey, including galactic structure and others. Okay, so we have a bunch of meetings coming up. I bring this up because, to open up the hood underneath of what we're doing, just because we're looking for people to join us, and we're pretty open in what we're doing. And so, if you're just interested in kind of dropping in and listening on what we're doing, a lot of it's technical, a lot of it's in the weeds, but some of it, you get a sense of how the machinery is being made and how you might want to participate. So in particular, if you're in the Goddard area, or even if you're not and have your own funding to travel, we're going to have an all hands pit meeting this fall at Goddard Space Flight Center, probably sometime near the end of October. And we welcome people to join and just kind of sit in, or if they want to get involved, they can do that. And then there's other meetings as well. So we're always looking for more help. Contact me. This is my email, or any other PIT member if you'd like to get involved. I want to emphasize no microlensing experience is necessary. We will help train you in microlensing in whatever you need to do whatever it is you want to do. There's a lot. We're developing tools and tools have been developed that exist that allow you to make microlensing light curves, to fit microlensing light curves, to predict galactic microlensing event rates, all those kinds of things that exist and are user friendly, and we're developing more of them as time goes on. And so, so the bar is not as high to get involved with microlensing as I think the perception often is in the community. So with that, I will take questions and say thanks.
Question for Scott. Dave.
Well, I had a comment rather than a question, just to tie Scott's talk into the previous two and the next talk. The Argus Pit is also trying to help organize a free floating planet meeting, possibly in Osaka, and the idea is to attract a lot of theorists to try and explain where, how free-floating planets might form, and this would include, very wide orbit planets where the microlensing is not revealing the host star. So if you're interested in coming, we'd like to talk to you. We're trying to figure out what a good time is, probably either late this year or early next year.
Yeah, thanks, Dave.
No question online, no. All right, so in the interest of time, we're going to move on to our next talk. So thank you again, Scott.